Chapter 7, Section 1. Problem number 1, the distribution of blood types for 100 Americans is listed in the table below. If one donor is selected at random, find the probability of selecting a person with blood type A positive. So to find the probability of A positive, you look at the table. A positive, you have 34. So you have 34 divided by 100, and that is equal to 0.34. The next problem, if one donor is selected at random, find the probability of not selecting a person with blood type B positive. So the probability of not B positive is equal to 1 minus the probability of B positive. So 1 minus the probability of B positive is you have 10. So 1 minus 10 over 100, and that is equal to 0.90. Problem number 2, you have a dice problem. So here 2 dice are rolled at the same time. The set of 36 equally likely outcomes are given in the sample space below. Find the probability of getting 2 numbers whose summation is less than 6. So the probability of getting 2 dice whose summation is less than 6. Looking at your sample space, you have 10 outcomes whose summation is less than 6. So you have 10 total out of 36. So 10 out of 36 is 0.278. The next problem, find the probability of getting 2 numbers whose summation is greater than 10. So the probability that the sum is greater than 10. Again, looking at your sample space, and you've got 3 outcomes whose summation is greater than 10. So 3 over 36 is 0.083. And the last one for number 2, find the probability of getting 2 numbers whose summation is 5 or 6. So the probability that the sum is equal to 5 or 6. So here you have 4 whose sum is equal to 5, so 4 out of 36. And you have 5 whose sum is equal to 6, so 5 over 36. So the summation of 5 or 6 is a total of 9 over 36, which is equal to 0.25. Moving on to problem number 3. Here we have a card problem. So a card is drawn from a standard deck of 52. Find the probability that the card is a 10. So the probability that the card is a 10, you have 4 10s in a deck of 52 cards. So 4 out of 52 is equal to 0.077. Find the probability that the card is a heart. So you have 13 of each suit. So you have 13 hearts, 13 spades, and so on. So 13 out of 52, and that is equal to 0.25. And find the probability that the card is a 7, club 7. So the probability of the card being club 7, you only have only one club 7. So 1 out of 52 is equal to 0.0192. And the last problem, number 4, here you're given a following table which shows the number of students in 3 different degree programs and whether they're graduate or undergraduate. So before answering the problems, let us determine our total. So total of undergraduate is 400. Total of graduate is 100. And let's take the total of business. Total business is 200. Total of engineering is 175. Total of arts and sciences is 125, which gives you a total of 500. So now let us answer our problems. What is the probability that a randomly selected student is a graduate business major? So graduate business major is 50. So the probability that he is a business graduate, and that is 50 over the total of 500, which equals 2.10. The next problem, what is the probability that a randomly selected student has an engineering major? And here the probability of engineering is a total of 175. So the probability that the student is in engineering is 175 over the total of 500, and that is 0.35. And the last problem, what is the probability that a randomly selected student is not an arts and science major? So the probability of not art and science is equal to 1 minus the probability of art and science. So art and science major, you have a total of 125. So 1 minus 125 over 500, and that is equal to 0.75. And that completes Chapter 7, Section 1.